measure of the larger acute angle. Any idea how you might set this one up?
Well, I'd probably draw the triangle first so that I could
Good idea. So I'm
figure
gonna,
that out.
okay, so do you have a choice here? Which one should be the first acute angle, I guess?
We'll do the bottom right one.
Okay. And then what is the equation for the other one?
It would be 9x.
9x, good. And you could add all of them up to 180, but the other two angles add up to 90. 9x plus x add up to 90. So that allows you to find x, and you can use that to find the two angles.
Yes.
So to go ahead and do that for me, please, and let me know what you come up with.
Okay, so x should equal 9,
Yes.
which means that the other one would be 18, or no, 1881.
Yeah. So 9 degrees. And then the 9x is 81 degrees. Great. All right. Any questions on that or thoughts?
No, that sounds good.
Yep. So we'll just keep going here. I think the harder problems are these ones where you have to draw the triangle or draw something. It doesn't necessarily have to be a triangle, but it says the perimeter of triangle ABC is 28. If AB is 2x plus 3 and BX equals 4x minus 5 and CA equals 8x minus 19, is the triangle scalene, isosceles, or equilateral? To answer that, you have to decide what are the lengths of each side. So it would be a good idea for you to draw a triangle. If you don't know which one to draw, this is a good choice here. A, B, and C. Label the missing sides. So 2x plus 3, 4x minus 5, 8x minus 19. So you want to set the sum of those three sides equal to the perimeter.
Yeah.
And then solve for x. Once you have x, you can use it to find the lengths of the sides and see how many are the same.
Yeah, that looks pretty straightforward. For x, I got 3.5. I'm not sure if that's correct though.
That is correct. I was going to go 7/2, but that is correct. So the nice thing about that is that all the numbers do multiply into it. 2 times that gives you a whole number. 4 times that gives you a whole number, and same with 8. So you do have to keep going and find the other side lengths.
Each one. Okay.
I'm sorry.
Each one.
Yeah.
Yeah.
Yes. Each one, unfortunately. There's no
Okay.
shortcuts here.
Okay. Okay, I think it would end up being an isosceles triangle.
What did you get for A to B?
I got 10.
Okay, and for B to C?
9.
Okay, and then the last one.
Also 9.
Okay. Yes. So it is isosceles.
Okay.
Fantastic. So these lend themselves well to multiple choice. For example, they could have 7 halves. They could have, scalene, isosceles, equilateral. There's lots of ways to sort of present these types of questions as in an exam format. Do you have a copy of your midterm that you took, right before the holidays and all that?
No, she
You should-
doesn't let us keep our tests, which is
Ah,
dumb. But
yeah, it's one of those. Yes. All right. We'll save that for another time here. Do you think you will have any proofs?
I don't think so. We haven't really done any proofs this semester.
Okay. So that might be a good question to ask, just to double check. Hey, we're gonna have any proofs and see if
Yeah, I'll ask her.
because you don't want to get caught off guard if you haven't done one in a while. It's
Yeah.
like going out to do the chicken dance and you don't know how to do it. It's a little awkward. All right. PT, we're trying to find PT in the problem and ER. So I sometimes like to label the ones that we're trying to find, or to indicate, okay, we're trying to find that one. And then P to R is this one here. Okay. Do you remember anything about kind of similar triangles that you've got here? Anything come to mind?
Similar triangles. Well, if they're similar, the angles are still going to be congruent.
That's right.
Yeah.
These angles are congruent. You got some angles down here congruent.
And
That's really
then
good.
you can find like the ratio of sides also.
Yes, bingo. Yeah. Now, I like to do this. This is something if we had been working the whole semester, I would have showed you, right away. I would have said, sometimes it's good to label stuff in terms of the big triangle and the little triangle. SQP. So this is 18, this is 15, and this is 16. And the reason is it gives you kind of a mapping, like 12 goes to 18, X goes to 15, and TR goes to 16. Do you remember doing that?
Yes.
Maybe. Okay. So you could set up a proportion. You can also figure out the scale factor.
Okay. I don't know. I don't remember that one quite as much.
Okay, so let's not do it that way. So X over 15, I'll say, because that goes with this side here, equals 12 over 18.
Okay.
Okay, so this is it. And the way you set it up is you typically put either the information for one triangle in the numerators or one triangle on the left. If you go the same triangle in the numerators, then you have to always say, okay, well, what is X and what is 15? They have to sort of match up triangle to triangle.
Okay, so X equals 10 then.
X equals 10. I agree. Now, we didn't actually need that value for the answer, but we need it because it helps us to find PT. If we know that TS is 10, then we know that PT or TP is 5.
Yes.
That's our first one there.
Okay. Yeah, that makes sense.
Okay, now how do we find TR? TR, that's this one here.
Probably like in the same kind of fashion with
Exactly.
setting up a
Exactly.
proportion.
So Y over 16 equals, and you have your pick. I'm going to reuse the same ones again.
Okay.
So go ahead and solve that for us, please.
Okay. I did it on my calculator, so I have a decimal. Normally, if I wasn't feeling as lazy, I would like do the fraction part of it. But
Okay.
it came out to like 10.6 repeating, which should be like the same as whatever would be like simplified as a fraction.
That's good enough for me. So good review on that. That's why we do this. There's problems like, oh yeah, I haven't seen one of those in a while. And you don't want to see it for the first time in a while on your final.
Yeah, that's
Okay.
never a good idea.
The worst for me was when I in an English class where I didn't remember that we had read a book or a poem or something. I'm like, didn't tell you what it's about. So helps me to remember what it's like to be a math student. You just like, oh yeah, sometimes you just don't remember stuff. So
Yes.
all right, so this is two chords inside a triangle, inside a circle, two chords inside a circle. Do you remember the relationship between the lengths?
I feel like they're equal, but I'm not sure. I don't think they are. It's like they're like, oh,
The
there's like
product, the
we did
products
like
are equal.
yeah, the products are equal. Was it like there's like the chord power theorem or something like that? That
That
might be
sounds
on
right.
there.
Yeah. Yeah. Very good.
That's
So
probably something that'll be on there.
yeah, and I mean, if multiple choice, you would have answers that would potentially be like, if they think they're equal, X being 11, and that would be not correct. So yeah, I mean, good to kind of, now, do you know if you're going to get a note card, a reference sheet going into this?
I would assume no, because she's like the worst math teacher in the world, but like,
Okay.
I can always ask. She'll probably be like, no.
So asking is good because then you have expectations in the right place. And then you maybe still make one so that you can look at it between now and the final, that you're like, okay, I gotta have chord power theorem on there so
Yeah,
that to remember
I'll
it.
probably ask her if like unit circle is gonna be on there too.
That's a good one to ask as well. All right, so can you solve this one for X for us, please?
Yes. Okay, so X would be 18.
3X equals 24, and X equals 8.
Oh yeah, yes, never mind.
Okay,
So it's
okay,
I was looking at at two different ones. I multiplied two different things. It's on the same chord. So
got
yeah.
it, got it.
Yeah, got
Okay,
it, got it.
all right, now the other thing it might ask for is the length of like AB. That could be another question that it might be asked. So
So
something
then
to
you
think
would
about.
just say the length of AB is 11.
Yes.
Okay.
All right, so here we go. We got two triangles, two right triangles put together here. This is one of those where like you have to say to yourself, what do I really want? What I really need to find X, like what value helps me to find X? And then you go find it, or you start from the given information, you say, what can I find next? Which is the hypotenuse, then decide how that helps you to find X. Anything jump out at you here that you can do?
Well, I see a 3, 4, 5.
Yes,
And then I see a 5, 12, 13. So
so you're done. Now, let's say to make this a better question, I wanted angle theta. How would you calculate angle theta?
I'd probably do like right triangle trig.
Okay, good. All right, now here's another question that could be asked. Let's say this is A, B, C, and D. It could ask you for the perimeter of A, B, C, and D. which I think you be okay to find. What if you were
Yeah.
asked to find the area of or the total area of the two triangles? What would you
Okay.
do then?
Then I would multiply 4 and 3 and divide it by 2.
Good.
And then I would multiply 5 and 12 and divide by 2 and add those
Good.
together.
Good. Okay. Okay, that's good. These are all A problems, so they're not going to be more than a 1 or a 2-step type of situation here.
Yeah, she tends to put in a lot of like the C kind of questions and like all
Yeah,
the
and these lead to that, so
multiple.
we'll get there. Gonna warm up to them. Okay, this problem is about angle measures, arc measures. Do you remember
Yeah.
anything about these?
Yeah. Um, so if it's outside of there, it would be so like 12 degrees would be it would be x minus 20 divided by 2 would be what 12 is.
Yes, good.
So then it'd be 24 equals x minus 20. Then you would add 20 to the other side, and then x would be 44. I believe.
44.
Yeah, 44
Okay,
degrees.
now it should be in degrees in case that's being mentioned there. Really good. Yep, that's a nice problem here. All right, so for number 6, I'm gonna talk through it a little bit. All right, so it says 2 similar triangles have areas of 9 and 25. I'm just going to draw them here. This is the one that's an area of 9. This is an area that's 25. I probably should have drawn them the other way, so let me do that actually. So when you guys were talking about scale factors at some point in the course, the areas are always the scale factor squared for area. Area is k squared. Lengths are just k. And volumes, which I don't know if you guys did, is k cubed. That would have come up pretty recently. Like the 2 volumes, you'd find the ratio of the volumes and you'd find that it's some k value.
Yeah. Okay.
Okay, so this problem here, you have to recognize that the ratio of the sides is the ratio between these two, or 25 over 9, depending on the direction, but then you take the square root of each.
Oh, okay.
So it's like, it depends whether you're going from the smaller to the larger or the larger to the smaller, which doesn't really say, but your k is one of these. And you can see they're both up. You can take the square root of the top and the bottom, 3 over 4. So it just kind
Okay.
of depends which way you're going. And I don't know the answer to that. So this would be a good question to ask the teacher of something like, I was working on a problem where I needed to figure out the ratio of the sides, and I didn't know because the problem didn't specify whether it goes from smaller to larger, larger to smaller. Will it be clear in the problem? It's basically a from something to something.
Okay.
All right. So the next question here, part B, it asks about the ratio of the perimeters. The perimeters are lengths. So the lengths are going to be the same ratio as it's either going to be the 3 over the 4 or the 4 over 3. Lengths are always in the same ratio. It doesn't matter if it's multiple lengths like the perimeter, it's still considered lengths.
All right.
So this thing back here, excuse me, this would go on your reference sheet. Lengths K, area K squared, volumes K cubed. You'd want to somehow remember that.
Could you drop the like, I don't know if there's like you sent me like a trig like cheat sheet kind of thing.
Yes.
Could you drop that in the chat again? I'm on a different computer. Like I stopped using that
Sure.
one computer, so I need to re-download it.
Yeah, of course. Just a moment here to find it. See if this is the one. This is the one. All right, you got it there.
Yes, I see it. Thank you.
Awesome. All right, let's keep going here. Let's do the other thing I think that should maybe be occurring here is you might notice that these problems are not that difficult because you've seen them all before. I think there's a mistake to think that you are kind of the expert now. I mean, you know a lot of geometry right now, so these should be things that you're like, yeah, I know this. I'm not scared. All right. You don't have to necessarily find them in this order, but could you look at this and tell me if you can easily or quickly find anything else on the triangle?
Yeah, so that bottom, so XZ should be 8. So it's so
I
3,
agree.
4, 5.
I
3, 4,
agree.
5 times 2.
Okay. I agree. Now, the next thing I'll say here is that there's 3 triangles in this image on the right. And for example, um, they give you everything in the small triangle. And then there's this medium triangle over here to the right where you only know the short leg. But in the big triangle, the big triangle, um,
Oh, would
you,
that
you,
be
you
a 45, 45, 90?
that's coming up. This is uh this is the small, medium, and large triangle problems.
Okay, so we're going, the big one would be a 45, 45, 90.
No, 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 unfortunately. You
Really?
have to, you're using, yeah, that's why I'm kind of curious how you guys did this before. So you have to set up, like, for example, let's say you wanted to find, um, it's right here. You have to ask yourself, well, what is X? X is the long leg of the medium triangle, but it also now gives you the hypotenuse of the largest triangle.
Okay.
I'm feeling like maybe you've never seen this before. So let me try to
Yeah,
set it up here.
it's like, I don't know, there's just like, I feel like there's not enough
So
information.
there's
Like,
a small triangle, a medium triangle, and a large triangle. And there's a short leg, long leg, and hypotenuse. And you kind of have to decide what you have to be able to write a proportion. Like for the small triangle, you have everything. And for the medium triangle, you only have the long leg. But for the hypotenuse, I'm sorry, for the large triangle, you have the short leg. So for example, here, you just need 3 of the 4. Like, do you see how you have the small leg and long leg of the short triangle, small triangle,
oh
but not the
yeah.
long? You could find the long leg of the large triangle.
Okay.
And so like let's call that Y for the moment. Y, which is the long leg of the large triangle. So do we know like the long leg of the small triangle? Yes, it's 8. And then what else do we know in the small triangle? We know the short leg. The short leg is 6. And we know the short leg is 10 in the large triangle. And now you have a proportion that allows you to set up to find
Mm-hmm.
that missing one there. So having said all that, could you find y for us, please?
Yes. Okay, I got in fractions. I got 40 thirds. But I
Okay.
like for
Okay.
these.
Yeah, I mean, it may not be all that nice. Um, defines that was so x is the long. Oops, I missed the wrong spot. X is the long leg of the medium triangle. So you can set up a proportion with the 3 of the 4 to find that one. So it's like X over, I don't know, I'll pick the long leg of the short triangle, and then in the medium, then over the short leg, so 8/6, I think,
Mm-hmm.
or maybe it's 6/8 now. That's right. So they don't always work out nice, but you can set these up.
Okay. Okay, so with the medium long leg being that, would that how would I find the how would I find the hypotenuse of that with just that proportion with all of
Well,
that
once you find
X
all the
over 8?
sides, once you find X and Y, you have everything because the large triangle hypotenuse is 6 plus X,
Oh, okay.
and the medium triangle hypotenuse is Y, so you already have that.
Okay, so over there, X would be, do this really quick. X would be 32 thirds.
I think I might put this backwards here. X over. So the other thing that I should have done here, which would have been better, is to actually put the numbers in, and then it's easier to set up the so like the small triangle long leg is 8, the medium triangle long leg or short leg is 8, and then the small triangle short leg is 6. So X over 8. Yeah, I guess it is right. You said 32/3.
Yes.
Yeah, that's right. And that allows you to find all the rest if you need to. Like WY is, this thing right here. YZ is this right here. XZ is this right here. For whatever reason, the easier one to find was XZ. But
Okay.
they didn't have you do that first. All
Okay.
right. Right. Let's see here. So some of this is fairly recent because you've been doing a lot of area stuff. Areas of anything or, fair game. It says find the area of the trapezoid. To do this, you really need the area of the base down here.
Okay.
And they're trying to help you out here by saying, well, okay, this is a triangle. This is a triangle. This is 8 and this is 8.
And then that's a 3, 4, 5 times 2 also.
Okay. So what is the
So then
one down?
that whole bottom length would be 24 plus 15, which is
I got 12.
39.
12
Oh
plus
yeah,
15.
sorry, 12 plus 15.
Okay.
My brain isn't working. It's tired.
Yeah, I'm tired too. Yeah. Okay, that's great. It's like, okay, I found it, but do you remember the formula for the area of a trapezoid?
It's like base. It's like base 1. There's something about there's both bases in there. It's like
You're actually finding the average of the bases. So if you were to find the average of the bases, it
is
would
it just
basically,
base 1 plus base 2 divided by 2?
yes, times the height though, because what you end up doing is creating a square, a rectangle out of it when you find the
Mm-hmm.
average of the bases
Okay.
times the height.
Okay.
All right,
Okay.
so
So it would
go
be
ahead and calculate that for us.
okay. Okay, I got 168.
And there are no units for who knows why. All right. New problem here. I'm skipping some. Trying to think of things we haven't done. B is one we've done a bunch of in the last few lessons. Okay.
Oh yes, this thing. Ugh.
Yes. So the issue here is it's a circle. Area of a circle is pi r squared. Sometimes you just have to draw an extra segment to figure out um,
Oh
the
yeah.
missing so that tells you, oh, it's a right triangle.
Mm-hmm. And
Any
then
idea what the length is in this part of it?
that would just be 12. Yeah.
Maybe 12,
And so that would be 13.
13. So it's pi 13 squared or 169 pi.
Mm-hmm.
Now, what is the perimeter, the circumference of this thing? Do you remember that formula?
That's pi times the diameter.
Okay, we don't have the diameter, so you might go 2 pi r.
2 pi r. Okay.
Because you do know
So
the radius.
the radius is we just did it is 13.
Okay. This becomes 26 pi.
Mm-hmm. Okay, so that's the circumference around it. Okay. Yeah, that makes sense.
Okay, number 9 here. Number 9, given SPQR is an isosceles trapezoid, do you remember what that means about the trapezoid? That might be useful.
I think it just means the two non-parallel sides are congruent.
Yeah, it also means that the base angles are congruent.
Yes.
Okay, so angle S is x plus 40, which means that angle R is also x plus 40. It also means that the other angles are also congruent. So this is
Yeah.
2x minus 7 here and 2x minus 7 here. What is the sum of the interior angles in a trapezoid?
I want to say it's like 540 or something like that. I don't exactly
The sum is
remember.
n minus 2 times 180.
N minus 2 times 180. Okay, I need to
That's
remember that.
another note card thing.
N minus 2 times 180. So it would be 360.
Okay. So these four angles have to add up to 360. You have to solve for x and then put it in for angle R. It could ask you for really anything. Could ask you for like angle P also. You know, any of these are kind of reasonable to ask for.
Yeah. Okay, that
So,
makes sense.
so will you solve this for x for us and then figure out which is R and which is P?
Okay. Okay, I don't know if it's right. I got 133 over 3.
Does work out to be a whole number. So sounds like you've got a
Okay,
small
let me
arithmetic
see.
error.
Oh, it's because it's minus 7 and I added them. That's why. Okay, I got 49.
Fantastic. So that's x. Find angle R and angle P. Got to substitute that back in.
Okay, so angle R would be 49. Okay, angle R would be 89. I believe.
Is it 89 for angle R? And then how about for angle P?
Angle P would be 91.
91. Yes. Okay, very good. Right. So we're doing a good job here. We're kind of remembering a bunch of formulas and things like that. You were asking about 45, 45, 90 triangles. I'd like to briefly talk about those.
Mm-hmm.
So let's say this is 7 and this is 7. Do you remember the value of the hypotenuse from the two legs in a 45, 45, 90 triangle?
Is it x root 2?
It is, but what is x in this problem? What does x refer to?
7.
Yes. So the hypotenuse is 7 root 2. Very good. Now, if you forget this, if you're like, I don't, get to the final. If you do 7 squared plus 7 squared equals c squared, you get 98 equals c squared, and you work that out, you get 7 root 2. You would say, oh, I should have known that, right? That's what
Mhm.
sometimes happens.
Okay.
All right. All right. So let's go the other way. Let's say I give you the hypotenuse and 45, 45, 90. And let's say I tell you it's 16. How do you find the values of A and B in this case?
So 16 would equal x root 2.
Agreed?
And then it'd be 16 divided by root 2, and then you would just rationalize the
Yep.
denominator.
Could you work that out for me just to make sure you fully know the answer?
Yeah, that would just be 8 root 2, I believe.
8 root 2. Good. Okay. All right. So what you might want to put on your note card reference sheet is a better looking triangle than that one. X, X, X root 2. So that's the 45, 45, 90. The other one you need is the 30, 60, 90.
That one's used a lot more than 45, 45, 90, I've noticed.
And yeah, the reason is for a good student like you, this one's too easy. They need to challenge you, give you some more difficult stuff here. Okay,
Okay,
so
yeah.
let me give you a couple of these 30, 60, 90s to see where you're at. So let's say I give you that the hypotenuse is 15 and I want A and B, and this is 30 degrees here.
Okay, so then 15 would be x root 3.
X root 3 is the long leg side.
Oh, the longer side, sorry. 15 would be 2x.
Yes.
15 would be 2x, which means that x would be 7.5.
Okay.
And then b would be 7.5 root 3.
Good. Okay. So then the other challenging problem that you might see is where they tell you that this is 15, this is the 60, and they want y and x.
Okay, so
It's all about figuring out which one. Yeah, go ahead.
here actually 15 would be the x root 3. So
That's correct.
then you could figure that out by rationalizing the denominator like the other one, which would be 15 over root 3, and then you would do that and it'd be 5 root 3.
Okay.
Would be x, and then that times 2 would just be 10 root 3.
Okay. All right. Very good. Okay. So where does this all come into play? You mentioned this before. You're like, using this one a lot. You'll get an equilateral triangle. You split that equilateral triangle right down the middle. Okay, this is 5, this is 5, and then you have to find the altitude, hypotenuse. What is the altitude in this one?
Okay, the altitude would be, oh, because it's a 30, 60, 90.
Yes.
So the altitude would be 5 root 3.
Okay.
You could
And so
also,
from
if they're asking for the area, you could do the root 3 over 4 times the side squared.
yeah, that's where I was going. It's 1/2 base times height, 5 root 3. So it ends up being 25 root 3. Now again, another type of problem, which we're not going to do, but another type of problem where you see this all the time is that hexagon. Where they tell you something about this. They tell you that the altitude is 12, and you end up having to figure out that that means that this is 4 root 3, and that's 8 root 3, and you use some formulas to find area, base, and height, and all that.
Okay.
All right. So we stopped
Sounds good.
kind of right around, I don't know, I'll just say problem 11 or 12 in case you're wondering, but there's tons more to do here, but we'll have to stop here for today. I know it's been so much fun. Go ahead and stop
Mhm.
the recording.